Alright, so first we're going to talk about properties of an ideal gas. So first things first, a, an ideal gas is a gas that takes up no space and has no molecular attraction. With these characteristics in mind, we can use a general equation for any gas as long as the gas exhibits ideal gas behavior. So the equation for an ideal gas is PV equals nRT, where P equals pressure, V equals volume, N equals moles, R is a gas constant depending on what units you have, and T stands for temperature. So from this general equation, we can actually derive several gas laws that gases follow in real life. So the first gas law is Boyle's law. And Boyle's law, it pretty much means that as you increase volume, keeping all things constant, pressure should decrease, and vice versa. Now this makes sense because as you reduce the surface area, more molecules are colliding with the container or the volume, so that means pressure will increase. So for the next law, we have Charles's law. The law states as you increase temperature, volume should increase. And as you decrease temperature, volume should decrease. This makes sense because as you decrease temperature, the molecules are moving slower, so they won't want to expand as much. Thus, the volume will be reduced. The third and final law is Avogadro's law. Avogadro's law basically states that as you increase the number of moles of gas in a container, the volume should increase as long as all other things are constant. This makes sense because as you increase the number of molecules, more collisions are happening. So in order to keep pressure constant, the molecules must be more spread out. So to make them more spread out, volume must increase. Alright, so here are some practical applications to the equation. So first up, we have Boyle's law. And the law states that as you increase the volume, pressure must decrease if you keep all the other variables constant. So next, for Charles's law, If you increase temperature and keep all other variables constant, volume will increase. And then finally for Avogadro's law, as you increase the number of moles, volume will increase as long as all other variables stay constant, as you can see.
Alright, so this is Charles's law, and the law states that as you decrease temperature, volume should decrease. So we left this balloon overnight, and we're going to see if it decreases volume.
Let's do this on the floor over there.
Where?
Right there.
Where?
Alright, it was 13 last time. So,
It's still 13.
no, dude.
Yeah, dude.
Dude, it's going down to more like 11.
Alright, you recording?
Mm-hmm.
Okay, this is Avogadro's law, and the law states as you increase the quantity of gas, volume should increase.
So for our third and final demonstration, we will be demonstrating Boyle's law. And the law states that as you decrease the volume of a container, whether it be a balloon or a water bottle, pressure will greatly increase. As a result of this great pressure, because of the gases, explosive results will follow.